Assalamu alaikum dear students. Today we are going to discuss cosec and its inverse. You know that sine is a function from when we consider its principal branch values. Now sine is a function from interval minus pi by 2 to pi minus 1 to 1. Its inverse is function from minus 1 to 1 to interval minus pi by 2 to pi by 2 defined by g of x equals to sine inverse x. Here this means that the value of the sine x is always between minus 1 and 1. Also that cosec equals to 1 upon sine. This means that this cosec is defined for all points except those where sine not equals to 0. So this means that sine is 0 at n pi because sine n pi is 0. Hence this domain for this cosec x is r minus n pi because we are removing the points where sine is 0, that is n pi r minus n pi. So r minus n pi is the domain of this cosec. Now if we consider a function from this r minus n pi to r minus n pi to r defined by f of x equals to cosec x, so this is the required domain. Now clearly the value of this cosec is always greater than 1 because sine is less or equals to 1 and cosec is always less than minus 1 because cosec is always greater or equals to minus 1. So when you draw the graph of this cosec, it is simply in these intervals, it is like this. So at pi by 2 the value is 1 for this cosec. At minus pi by 2 value is minus 1, and at 0 and at pi the value approaches to infinity. So this is the required graph for this cosec x. This is the required graph of this cosec x, cosec function. Now clearly this function is neither 1 1 nor onto, because why it is not 1 1? Because here the points in interval minus 1 to 1 are not the image points, so that is why this is not onto function. It is also not injective function because different points have same images like pi by 2, minus 3 pi by 2, minus pi by 2 and 3 pi by 2. All these values are different, but their value is same, that is either 1 or plus 1. So when we consider, so this means that in order to find its inverse, we have to restrict its domain as well as its codomain, now restricting codomain. Now if we exclude this interval, open interval minus 1 and 1 from this r, then clearly each and every point outside this interval, that is from this side either or from this side, or the image points, which implies that the function becomes onto function. Now similarly, if we consider the domain in interval this, pi by 2 to 3 pi by 2, pi by 2 to 3 pi by 2, in this except pi, in this interval it becomes 1 1 function, but here in interval 0 and pi, if we consider this interval, it is still not 1 1 function because here it is 1 point, its value is like this star. If we consider another point, it is different from this point, but its value is again same as the given point, which implies that in this interval it is not 1 1. So this means that we have to consider this interval, this portion of graph. So when we consider the interval pi by 2 to 3 pi by 2 or minus pi by 2 to pi by 2, like this, like if we consider this function, except point here is 0, so it is a 1 1 function. When it is 1 1 onto function, its inverse exists. So we are considering here the interval minus pi by 2 to pi by 2, from minus pi by 2 to pi by 2, then it is 1 1 onto, and this graph is in this interval is like this. So clearly if we consider the same function from interval minus pi by 2 to pi by 2 minus 0, because we have to remove this point 0, because here the function is not defined, to r minus interval minus 1 to 1 defined by f of x equals to cosec x. Its graph is this, and it is 1 1 onto, when it is 1 1 onto its inverse exists. So when we consider the function from the codomain of this function, that is from r minus interval minus 1 to 1 to interval minus pi by 2 to 0 defined by g of x equals to cosec x. So this is the inverse of this cosec x, inverse of this cosec x. Cosec x. So any value of this cosec which lies in this interval minus pi by 2 minus 0 is simply called as the principal value. Principal value. When we draw the graph of this cosec in this interval, or the curve in this interval, are simply called as the principal branches. Here remember one thing, this sine x is equals to 1 upon cosec x, but sine inverse is not equals to 1 upon cosec inverse, or 1 upon cosec is not equals to cosec inverse. So this is important here to remember, that sine x equals to 1 upon cosec, but sine inverse x is not equals to cosec inverse x, because here these are two different things. It is the function from this cosec is the function from r minus interval minus 1 to 1 to interval minus pi by 2 minus 0, and its graph is like this, and these curves are simply called as the principal branches, and the value in this interval is called principal branch value. Now last another one is the cot. You know that cot is defined by cot equals to cos upon sine. Domain of this cos is r, domain for this sine is r. So this means that this cot is defined only at points where this sine not equals to 0. So sine not equals to 0, or the sine is 0 at n pi. So when we remove these points r minus n pi from this, so it becomes, if we consider a function f from r minus n pi to r defined by f of x equals to cot x, then this is the required domain for this cot x, because at each and every point of this r minus n pi this function is defined, or there is a finite value. So when we draw the graph of this in these intervals, it's like this. So this is the required graph for this cot x. Now clearly this function is onto function, because each and every point of this r is the image point. Now when it is image point, each and every point is image point, so this means that it is this onto function. But it is not one function. Why it is not one function? Because different elements have same image, like this, these are the different points, and the value of these points is simply same. So we have to reject, we have to restrict its domain. Now if we restrict its domain in the interval like 0 to pi, in this interval, open interval 0 to pi, because we have to, why we are considering here only the open interval, but not the closed, the we this is the reason, because at point 0, at the end points of this interval, the value is not equals to the finite number, it is infinite. That is why we have to consider this open interval. Now if we consider the open interval 0 pi to r, then it is 1 1 on to, like here we have 0, this is pi. At pi by 2 the value is 0, when value is 0, so this means that the graph is like this. So clearly this function is 1 1 onto function in this interval. Now when it is 1 1 onto, this means that its inverse exists. Now if we consider function g from r to interval 0 to pi defined by g of x equals to cot x, this function g is called as the inverse of this cot x, which is called r cot function. Now any value of this cot inverse which belongs to 0 pi, is called as the principal branch value of this cot inverse. So inshallah in tomorrow's video lecture we will discuss another function, that is a sec x and its inverse. and we will find the principal values of different arc trigonometric functions. Thank you.